AI technology analyzes and diagnoses energy loss factors at production sites. Energy saving support software, EcoAdviser. We are going to introduce a case study of using the energy saving support software, EcoAdviser, in the manufacturing facility for instrument transformers at Mitsubishi Electric's Fukuyama works. An instrument transformer is a device that converts a high voltage into low voltage, or a large current into a small current of an AC circuit. This device is encapsulated in a molded plastic. The equipment here uses a lot of energy for resin molding, so we realized we need more effective energy-saving countermeasures. Accordingly, we implemented energy-saving activities with the help of EcoAdviser. First, we needed to understand the current situation, so we visualized a huge amount of data with the graph function, which led us to realize that the curing furnace consumed the largest amount of energy. We focused on the curing furnace and analyzed the data. And from the transition of the product input rate, we were also able to confirm that the input efficiency was low. We implemented countermeasures to refine our production plan in order to improve the product input rate. Next, we use the AI diagnostic function to identify the energy loss automatically. As a result, 2 points, loss of curing furnace startup time and specific energy consumption, were identified as items with a large loss. After that, we diagnosed the energy loss factors. Regarding the first identified item, the loss of the startup time of the curing furnace, the main factor of the loss indicated was the startup of the curing furnace at around 10 o'clock. Based on EcoAdviser's advice, we checked the startup time and the graph for the days when the loss was very large. Because of our lunch break, we interrupted our product input. Due to this interruption, the curing furnace was idle, waiting for input to resume. In order to eliminate the amount of idle time, we found we could improve the operation by delaying the startup time to around 11 o'clock. Furthermore, other curing furnace loss factors indicated by AI were the startup of the curing furnace at 7 o'clock and the startup of production at 11 o'clock. A detailed investigation revealed that the startup time was about 30 minutes earlier than the average startup time of the curing furnace, required in order to start production. As an operational improvement, we considered and implemented a delay in the startup time. The second identified item was the specific energy consumption. We focused on the differences in the specific energy consumption of each curing furnace. We found that the specific energy consumption of one curing furnace was about 3 times larger than the other. We investigated the inside of the curing furnace that had a poor specific consumption, and we found the exhaust damper had not been adjusted properly, and that there was wasteful power consumption due to the leakage of hot air. This result led us to investigate and to repair the dampers of all the curing furnaces. Based on the energy loss factors, advice indicated by AI and daily graphs, we found energy-saving items that would have been difficult to discover manually. These results have been achieved with Mitsubishi energy-saving supporting devices, such as EcoWeb Server 3. The energy-saving result, achieved using EcoAdviser, works out to an energy cost reduction of about 1.4 million yen per year. Mitsubishi Electric's EcoAdviser dramatically improves the energy-saving activities and changes your performance better.